everyone, and welcome back to another episode of Reliability BoomBox, proudly brought to you by Reliability Extranet, Sologic, and Reliability Analytics. Anyway, they're our little group of companies which you'll soon get to know. I'm Dane Sullivan, and my co-host here, Peter Horsburgh, or Seven. Welcome, Seven. Nice to have you back.
Thank you very much. I'm looking at a little casual today.
Oh yeah, we like to keep it casual anyway. In real, you don't get as much casual as if you can see him. I'm sitting behind a fire pit.
Oh, awesome!
Keeping yourself warm outside. Yeah. So these first few episodes, we're just trying to kick into the whats, the whys, the whens, the whos, the what ifs of good reliability engineering practices and the tools that are out there, and in particular two tools that we like to talk about and use in RCAs, or problem solving, and machine learning. So kicking it straight off the bat, let's kick into when is a good idea, or when do you need to do an RCA? I think in my experience, from working in the industry for as long as I have, RCAs are kind of, they're like, oh, do I do one here? Do I not do one here? And each company or organization I've worked in have got their own metrics of this level of incident or this level of action needs to have been taken before you get targeted. Though, from your point of view, what would you say is a good time? And yeah, let's just start there. When do you think it's best to consider doing an RCA?
I always sort of live by the motto that you only suffer the pain once. So if something occurs twice, 3 times, 4 times, 5 times, really it's telling you that you don't actually understand the problem because it's reoccurred again. Yep. And obviously, it's if you've got a reoccurring problem or a chronic problem, is some of the words that I use in the 5 habits, that is a prime candidate for an RCA. But obviously, if you talk risk and frequency, I've just talked frequency and consequence. And so when something big happens, and obviously you don't want that to happen again, that is another prime candidate for an RCA. So, or structured problem solving. Okay, because it warrants the effort because of the loss. Right. So think of it as a return on investment. That you're going to make a little bit of investment in your time doing the problem solving.
Yep.
Okay, so that you understand the problem, so that it doesn't occur again. That's the crux of it. That's the crux of it. So think about it as a return on investment. So if it's worth the return on investment, do it.
Yeah. And I think when we're talking about problem solving and RCAs in general, probably one misconception I've noticed is that they're time consuming always, and that they are complicated, or can sometimes be a bit of a drawn out process. Though what I've started to learn and understand in dealing with Sologic in particular, and seeing some of the other methods, is that we can simplify them. And a simple RCA, or a simple following the process through, even if it's for 20 minutes in your own time on a small failure or a small reoccurring maintenance issue that you might have come across, can be a really good return on investment, like you've just said. So you could have constant, we're always tightening up this right wheel on a particular truck. Every time it comes in, that's loose. Let's do a quick RCA, and you might sit down with one of your colleagues for an hour and do it. And if you're following the process, it makes it quite simple, and that process becomes more habitual and easier.
Yeah. So rather than used the word process, right? Can we change that word to framework?
Yeah, perfect.
It gives you a framework to solve problems. That's what structured problem solving is all about. Okay, and then in the Syllogic problem solving world, it's 5 steps.
Yeah.
Okay, a framework of 5 steps to do. And I totally agree with you that you need, obviously, part of what would you call the skill set, the mindset is, or the knowledge is understanding is how far you go. All right. Yeah. Again, it comes back to that return on investment. You could follow the process verbatim and leave no stone unturned. But again, in the Syllogic process, we have the option to say, well, we're going to stop right here because we don't see any value. Of proceeding any further. Like when I'm facilitating Syllogics, I always come back to the Hitchhiker's Guide to the Galaxy. What's the answer to life, the universe, and everything? It's 42. Yep. Okay, we don't need to go that far. We don't need to build a computer the size of the planet to answer that question. We only do what is necessary to come up with the actions or solutions to solve the issue. Yeah. Okay. And solve the issue with confidence.
So just on that, a question that sort of came to mind, sort of associated with the when is a good idea. When is it a good time to do just that, to end the process or to go, yes, we found an appropriate solution, and we can sort of now move on from here?
Yeah. In my experience, when it's outside of your control.
That's outside of your control.
Control. Yeah. So if you could imagine there's a circle of control, you live inside the circle and you can control inside the circle. Mm-hmm. Once something goes outside of that circle and you can't control it, generally that's where you stop. For example, why did a manufacturer design a piece of equipment the way that they did? Outside of our control. I don't know. Sure. We just bought it and used it. Right? Yeah. Well, okay. I've got no idea, right, what they were thinking when they built that. I wasn't there. I don't know. Yeah. Yes, we've got a problem with it. Is that piece of equipment actually fit for purpose? Maybe, maybe not. That could be the thing. That's what you can say. But why in the hell did they, make the decisions that they did? We stop there because that's outside of our circle of influence. That's outside of our control. We can't change that. Yeah. We can't change that. So that's when I say, righto, okay, I'll pull things up in an RCA and I will ask the question, is this outside of our circle of influence? And if the answer is yes, we make the decision potentially to stop. Yeah. Okay. Different story if the designer is there. Okay. Yeah. Different story if the designer is there. Completely depends on the situation, but that's a general rule of thumb. It's outside your circle of influence. It's probably more productive to concentrate on the things that you can change.
Yeah, and I think if you're doing a large RCA where you're, you come across such a roadblock, it might be the case that you go, okay, well, we can't influence this aspect of it. We're going to earmark it and we're going to put it up here. We're going to make sure that we close off all the other strategies, all the other potential solutions, and see what other things we can do that are within our circle of influence. Mm-hmm. And then we may revisit this with the right people in the room. We might come back to the OEM or the original
equipment manufacturer,
manufacturing, or the designer or whoever actually has produced this roadblock for us, and have a conversation with them and gather some data, collect a bit more information from them in that to build our framework a little bit better and follow that.
if you start to engage in those conversations, then you've already done the pre-work, and the OEM saying, well, hold on, you guys have done a lot of work at this. We can see that you've really, really tried, and we can see where our design is causing the problem. That'd be a far more constructive conversation than saying, hey, you've just got to change your design.
Yeah, exactly. Yeah. So, and I had another question then, but it kind of escaped me for a moment. In a smaller environment, would there be a situation where, or have you come across situations that you've gone, well, hang on, let me rephrase that. How do you know when to stop? What's a good sign of a good solution or a good action? And in the Sologic framework, is there, I know the answer to this, so I want you to address it in your terms. What process do they have to actually identify there is a good solution, that you have actually appropriate answer to then go stop? Okay, we've got the solution for the RCA. We've found the potential root cause. Can we now stop?
But there's not usually one root cause, Dane. There's usually more than one.
Okay.
Root causes, all right?
Root causes. Okay.
Yeah.
Oh, everyone, happy to be corrected on that one.
Yeah. There's usually multiple factors with any problem. It's complex. Some things are complex. It's not simple. If it was simple, we would have fixed it.
Yep.
Yeah. Anyway.
So even on that, like, I guess natural instinct, and we've talked about this in some facilitating, sometimes our instinct is to find a potential problem. We go, oh, there's our solution, quick, let's go fix it. And it become a Band-Aid. Or people in a hurry might go, oh, there's a solution, and yep, they should be right, let's go fix it. So what keys do we have to actually identify, yes, these are suitable solutions, these are adequate information, and these are all the potential solutions that we have? We can now action them.
Well, you're starting in the right thing. One, can we do it?
Yep.
Right. Two, does it provide a return on investment, a positive return on investment? Three, does it have any sort of negative effects? Right. You've got to see, like, if I implement this, just have a stop and think. Are you going to leave a trail of destruction behind you, or a whole heap of consequences behind you as a result of doing those? So I really like when people come out with the innovative solutions that are in the elimination, substitution, and engineering space, where they come out with ideas that they wouldn't necessarily have thought of before.
Yep.
Okay. So I like that creative. I'm an engineer. Creativity doesn't usually, and engineering doesn't usually mix together.
No, they don't.
But I actually get a kick out of seeing people come up with, or coming up with myself, some innovative left of field solutions that wouldn't be sort of mainstream or the norm of what somebody would do. Okay, out of the box solutions, another word. But when those ideas come out, you've always got to give them like a litmus test to interpret. You've just got to make sure that you sort of meet that criteria, that one, you can do it.
Yeah.
Two, it doesn't have any negative consequences, and sort of three, it gives you return on investment of actually doing it. Obviously you can fix anything if you chuck enough money at it.
Yeah.
Okay. But money is a finite resource.
Yes. I think, I don't know whether it was in the podcast from last week or Or not, though. The other day we were having a conversation. I think you once said you had a manager that's like, in these situations, you've just got to keep sending money at it and,
spend.
and just got to spend money. All you can do is spend.
All you can do is spend. That's it.
Yeah.
In this situation, all you can do is spend. And you know that conversation will sit with me for the rest of my life.
Yeah. I think it's really important to understand that we don't always need to be in that situation. You know, if we get onto this early, if we are proactive in identifying the true problem or the root causes, then we can be proactive in solving them. We can make things better for us, for our operations, for our own well-being. Because let's be honest, if we're involved in the RCA for any reason, we have some level of care for what piece of plant or equipment that is being investigated, and it's in some way your responsibility. So you want to make your job easier and less stressful by actually doing a quality job in the RCA investigation and making sure that it is ended with appropriate solutions, and that those solutions do follow and meet the criteria, and that they are achievable and possible to be done.
You even should look at that they've actually worked. Okay, because everyone moves forward with the best information they have at the time, right?
Yeah.
Okay, and we're very evidence-based. We like to see evidence of stuff, so you've got confidence that the solution will work. Okay, but there is occasions where it doesn't. There is occasions where it doesn't, and you have to go, oh, okay. If that's the case, I think people need to take that as a learning point and say, hold on, we thought this was happening. Evidence was showing this was happening. However, our solution addresses that problem and it didn't work. And that's a learning point when you go, wow, why didn't it work? Because of, X, Y, Z, 1, 2, 3, whatever new learning pops up. Now that's continuous improvement.
Yeah.
Okay. And everyone, over the years in my corporate life, that word has been used a lot. All right, has been used a lot, and that's the essential thing about continuous improvement is that you're continually learning and doing new stuff, and and using a structured problem solving process allows you to start dipping your toes into that space.
Awesome. So then moving on to the machine learning side of things. As we've discussed, machine learning is a bit of a new process here for us in Australia. Anyone in other countries that might be a little bit more up to speed with it, we certainly love to hear your input and thoughts on it. So in your mind, when is a good time to consider using machine learning platforms or machine learning tools in your experience?
When you need early warning of impending problem would be my answer to that. Okay. Now, and the consequences of the plant going offline is fairly substantial, i.e. there's it's a big decision to take it off. If it's like a constant sort of process, lots of money involved, startup costs if you lose it, if you have to stop the process. So, or you've got, logistics. If you're in a remote area like where you probably are at the moment with your fire in Australia, we've got a lot of remote areas here, and a lot of people and plant and business in remote areas, to the point where they've got to fly people in and out. So the FIFO, we call it FIFO, fly in, fly out type things, and you're in a remote place. I was working for some people in a remote area, and they had numerous pieces of plant down waiting on parts.
Yeah.
So the only thing stopping them from fixing it is the parts actually arriving. And I think it took something like 2 days to drive it from like a major capital city to the location via a truck. Okay.
Yeah.
So some of these parts are, you need the Antonov, the big plane to fly it in, and whether the Antonov could actually land on the airstrip, I'm not 100% sure. But anyway, so even simple things like that, where you need that lead time. So if you could imagine have early warning that something's going to occur so that you can organize the parts, that'd be a classic case with the machine learning side of things. And, the whole gambit of machine learning is to give you that early warning. Okay. Data scientists like data, reliability engineers like plant, and data is a tool to us. So, we can use, some of the tools and techniques in the data science world to give us that early warning that an impending problem is about to take place. The more earlier warning, the more you can intervene. So if the problem, and I'm not talking about, I'm going to diverge from reliability into the operational space.
Yeah, awesome.
So imagine if you understood that your process is starting to deviate from the norm, i.e. behaving subtly different, and the machine learning's picked up and it's going, the process, like this part of the process is now behaving differently. You could intervene to get the thing back on track.
Yes.
You could intervene to lift the quality of the outputs out, because it may not be at the point where it stops something, but it could be at the point where the quality is starting to deviate, and everyone's trying to get the most, and I'll come back to this philosophy, get the most out of something costing the least when they're finished with it, and it's part of that. So if you're in that headspace, I think machine learning is definitely a tool in the toolbox that you should consider.
So one of the things some people use the word
digital twins for the process.
Digital twins. Okay.
Where they actually make a digital twin of the plant, and have applied machine learning to optimize some process. For example, on a boiler, optimizing your fuel inputs for an output. So you can use machine learning for that. Now I'm deviating from my normal space, which is reliability. Now I'm into the operations space, but you can use the technology for that. Is obviously getting back to getting the most out of something costing you the least when you're finished with it. That fits into that space. Now, from an environmental point of view, that'd be a good thing too. So if we're not burning or being inefficient with the fuel, we're actually maximizing the use of the fuel for the outputs. We can use machine learning for that. And people, you commonly use the word digital twin. Make a digital twin of the plant, and the machine learning understands how it should operate. And whenever there's a deviation or an optimization to be done, it can do that.
Yeah. Okay. Awesome. So I get that there's multiple facets. I love that you went into the operation side of things and even the environment and so forth. And from what I've experienced and from conversations we've had offline, really, if it can put out data, it can be analyzed and processed in a turn. So if any piece of machinery is there and it has a data output, or there's a number of data readings, let's talk environment, say weather charts, we can actually associate poor weather. Like here in Australia, we've had a large amount of volume of rain for a bit over a week, and it's caused some damage to a number of places.
Yes.
And for those that have worked in or do work in the mining industry, understand that the effect of water in the mining industry, basically some of them, especially the open cuts, are big giant holes and can become very big ponds very quickly.
Lakes.
Yep. So you could even, there's an opportunity in the sense that you can even add other data that, look, there is a potential weather issue here. You need to start, majority of our water comes in here. We need to empty this so that this can go here. And it can help improve the process. It can help prevent other issues.
Explore options in the digital world so that you don't have to actually physically do it.
Yeah.
So you're not burning a whole heap of cash. So imagine trying to simulate a water event. Buying a whole heap of water and shoving it somewhere. It's just impractical. And essentially that's where the some of the power of the machine learning and stuff like that is what if if I get back to my space in reliability, false positives. So one of the conversations that generally happens from people sort of dipping their toes in this is false positives. Okay, so where the machine learning saying, hey, there's something wrong here, but it's not really.
It's not really.
Okay, it's not really. Okay, and it comes back into this thing of testing. So, we come up with the word dojo, right?
Yeah.
Offline prediction is the technical term. Put the bot or the machine learning agent or whatever you want to call it into the dojo and test him, and throw a whole heap of things at him and see if he actually works to eliminate those false positives.
Yeah.
On the flip side of that, that's obviously eliminating false positives. But imagine if you could run your plant in the digital space, right? Run your plant and see what happens. If you turn this dial this way or change a part of the process because commercial pressures are there to do so. Right? And what's going to happen? How's this place going to run? What's going to happen to the process? All that sort of stuff. That's when you could use it as well. And I know there's numerous obviously competition, trying to be relevant in the marketplace, all that sort of stuff comes into play there. Where you could actually experiment and see what you can do and where you can push the limits and boundaries and stuff like that with different bits and pieces.
And I think that really highlights the opportunity for machine learning, especially with it being so new for us here in Australia. And I'd probably even be willing to say it's relatively new in the United States and other areas of the world as well. Like, I think data analysts have been doing a lot of the work for a long time, which is fantastic, and they've done a great job at it. Though being able to implement the machine learning tools, you're covering off a lot more space a lot quicker. And with the way that the world is moving, as you said, trying to squeeze every little bit you can out of every little piece of machine and have it work and run as long as you possibly can, we're even removing the guessing game, and we're allowing ourselves an opportunity to make things last longer, by getting that predictive call for failure, or like the warning signs that little bit earlier, even if it's a couple of hours earlier. That's
could make
better than the boom.
Could make a big difference and consequential damage. So I was actually thinking, I ride a motorcycle. I was riding it today at lunchtime to go to an appointment, and I was saying to myself, I was thinking about this motorcycle, and obviously it's made of different metals and plastics and all that sort of stuff. And I said, I actually thought to myself, what's the one thing that if it failed would cause me to basically throw an engine away?
Mm.
And the answer was oil.
Right. Okay.
It's like the blood of a piece of equipment. If you get the oil wrong, okay, you're basically throwing the whole thing away, aren't you? And I was going, wow, okay. So imagine if you could apply machine learning to oil to give you an earlier prediction of a problem. In fact, I've already seen it. I've already seen it done in numerous occasions in Australia, where people are now applying machine learning to oil sample results, and they're getting early predictions. So early predictions of bearing failures, early predictions of failed head gaskets, and that's coming through oil analysis. And the machine learning tends to pick up the subtle differences in behavior earlier than what you or I will as humans will.
Yeah, I think that's a really good point. And remind me to come back to my thoughts on oil as well from the electrical standpoint.
Yes.
But yes, that one thing I think we might have touched on it before is that with oil, for example, by the time you get your oil sample, you take it away, you get it analyzed, and it comes back to you. And then you've got to look over it. And for you and I, if we're busy, we're looking at a page, we've got 50 oil samples that we've got to look at. We're looking at a bunch of numbers. We've got a memory bank of which numbers flag up if the report doesn't come off with them red anyway, or which combination of numbers flag us to go, there's something wrong there. And we scan it, and then we're like, yep, file it. And that's kind of it. Or we should do something. But by the time that we've got that, it's 3 days past. So if we've got to pull a truck in or something else, we're like, oh, hang on. We need to do something about this yesterday. Oh, yeah, well, we've now got the alarm. So
yeah. It's now broken down the paddock.
It's broken down the paddock. And this is one of the things that actually started to excite me when we started talking about the oil opportunity, because coming from the electrical background, transformer oils. So we used to, one of the company I once worked for, one of our catchphrases was doing oil sampling was like taking blood tests for your high voltage network. And it is.
Yep.
And it could tell us a whole lot about a transformer. I was blown away when I started to understand it and all the subtle differences. And it's been one thing for me to really get interested in seeing how we can do that better, because the cost to mines, like for some transformers, you can't have them on. You can't be in the yard when you're taking that oil sample. I mean, you don't want to stand right next to a 22,000 volt, terminal only half a meter away from your head when you're trying to collect a little, 500 mils of oil just for it to get sampled, do you? Like it's not a place that you want to be standing. So you've got to shut the whole plant down or the whole piece of equipment to do this. But maybe with a simple device and some machine learning algorithms, you're no longer actually needing to do this. You're no longer needing to do it as consistently and as regularly if you can just get some, even if it's basic data on that.
And that I totally agree that and the Internet of Things, right? So the I'm going to use the word plethora, or I'll interpret. There's so many options now with the Internet of Things, because all these device manufacturers now are following like Internet standard protocols.
Yeah.
Right. Which really means it's really, really easy to integrate devices right? So whatever the device is, whether it measures temperature or dissolved gas in a transformer, or water in oil in a hydraulic system, just to name a few off the top of my head. They're now, like, more and more manufacturers are now basically following internet standards for communicating.
Right.
What does that mean? Everyone understands it. It's really easy to get all that information into one spot. So coming back to your question now, when should you get into it? Well, now.
Yeah.
Now the opportunity is there, and it's not like you're not spending tens of thousands of dollars anymore.
Yes.
The devices are down to hundreds of dollars.
Yeah.
Okay. And what's the aim of the game? It's to give, like, the machine learning could take I'm going to use vibration. Okay. So online vibration systems and stuff like that. So machine learning is really, really good at recognizing subtle differences in behavior. So what does that mean? Well, you don't need to go the full gambit if it warrants it to diagnose that you have an outer race fault on this particular bearing. Okay.
Yeah.
Okay. You could install a lower cost, a simpler device on the thing to say, hey, the vibration's just changed on this piece of equipment, and the machine learning's just picked it up, because the machine learning's seeing a sample every 30 seconds or something like that. Yeah. And that's quite doable for, hundreds of dollars.
Yes.
Per device.
Yeah.
It's not like when I was doing, if you wanted a online vibration monitoring system when, like, I was in corporate life, you wouldn't get much change for $30,000.
Yeah.
$30,000.
Yeah, and I've worked at sites where they've got vibration guys doing vibration monitoring all day, every day. Yeah, like they're going around and doing the pumps and the bits and pieces all the time.
I used to have a guy working for me full time, and then we got two. So the went on the machine learning now, and getting things connected, it's not big money anymore. It's not big money. I think so, and there's more and more options for people with devices. It comes to that. If you understand the problem that you're trying to solve, understand the symptoms, right? You can pick the devices that will give you that basic information. It doesn't have to be complex, and it can be just basic information, and the machine learning can pick up on the difference in behavior, and Bob's your uncle, you got warning time.
Yeah, I think that's a really beautiful link there, is that when you actually understand the problems that you're trying to solve, or when you're understanding what the largest pain point is, like if you had, like we talked about, some remote plants and so forth that are around, and we get them a lot in Australia, you might not want to put machine learning on every piece of plant equipment or every aspect of that remote plant, but you'll go, what's the biggest thing that's going to go bang? Like you said with your motorcycle, what's the one thing you're going to sample the oil, or you're going to change your oil every time you ride it, or whatever you want to do to get the best out of that bike and make sure that it doesn't die. So that's when you should consider putting some machine learning on that piece of equipment, or on that aspect of the plant.
Yeah, and if the piece of kit stops, it's going to cause you pain. Like, in context, my motorcycle, if it stops, I'm going to be stuck on the side of the road somewhere. But if it was, it'd be a different story if that was, say, a hydraulic system in a manufacturing plant, or a hydraulic system in a power plant, or something like that. It'd be a different story if that hydraulic system stopped. The business consequence would be far, far higher than my $3,500 secondhand 20-year-old motorcycle. but that's where we're at with the machine learning. Like, I think actually I had a conversation today about about being aware of what to feed the machine learning. Okay, so this particular guy didn't. He said, "What? I haven't got the data," and I said, "Well, you do. You've got your SCADA data. You control the plant somehow. So data's there. That's where you start. You start with your existing data, and then if you can't detect if the machine learning doesn't pick it up, then you go, aha." Yeah. We understand now that it can't pick it up. Why? Because it can't see the subtle changes in behavior with the data that we're feeding it. Okay, we need some extra data. Let's go and look for some extra sensors. Yeah. And you're looking at $300 Australian for some.
Yeah. That's the thing in being more involved in this space. Like, I agree. Like, when I was back working with the transformers, like doing the process, it was tiresome, and no one had the idea or the other ways of doing it. But now you can get the thing the size of a hockey puck. Not that we play hockey here, but very much. But like,
I thought we were quite good at hockey in Australia, weren't we?
Oh yeah, but that's with the ball. I think hockey puck's ice.
Sorry, ice hockey. Yeah, that's a bit of a problem in Australia.
As a puck.
Yeah.
Sorry. But yeah, like you can get something like that and mount it on. Actually, randomly, I saw this the other day. Today, we were looking in a little book about camping caravan things, and there's a device that you can stick on the bottom of your LPG gas bottle, your barbecue gas bottle, to tell you if it is actually empty or actually still has gas in it. Because often it's not always 100% empty. And so there's all these little devices that you can just stick on there. It connects to your phone or it connects to something. There you go. Data's being sent. Yeah. And that's where
I think it was in New Zealand. I actually went over to New Zealand. They've got like a little device that sits on top of your garbage bin, right? It tells you when your garbage bin is full, like for councils and parks. Yeah. Garbage bins and parks, so they're not just having to, they can target their routes instead of someone going along and checking the bin. They have a little battery-powered device to say the bin's full,
or a solar-powered one, because you can get them pretty easily these days. A little quick one.
Yeah.
Wow, that's a beautiful thing. Because I've watched a number of places here. Like, we're traveling around. We're camping. We spend a lot of time at playgrounds and parks and things like that. And a number of times I've seen the garbage man come up and literally run around and he runs. There was one guy, literally, I reckon that was his exercise for the day. He was running to all the different bins, running them back to the truck and emptying them all. And it's like, wow, it's really quite time consuming. And he's probably on a time frame where he's got to try and get that whole route done. And, if you could find a time to save yourself some time by just telling you which bin's empty. Yeah. So awesome. Well, I think that just about wraps us up. I think we've covered off when is a good time to look at RCAs in problem solving. And just a reminder, it doesn't matter whether they're big or small. If it's a recurring problem, if it's something that has come back a number of times or is big enough to cause a large volume of pain or has caused a large volume of pain, RCAs or problem-solving frameworks and strategies are worth using. And machine learning, basically get onto it now, because more and more people are utilizing it. More and more data is out there and available, and it's not as costly as it used to be, but also it can really help you save on your plants and just giving you that heads up, or even on the operation.
It's not just in the reliability space. That's right.
No, it's certainly in the operational space and other areas. So wherever you can get some data, process it and learn it and solve those pain points.
Yeah. So it's interesting. We've actually done plant, people, and process. So I had a boss that used to say, your problems are either caused by plant, people, or process, right? So reliability engineers are definitely in the plant space. the obviously the operations and the process engineers are all about process, but we all get influenced by people.
Yeah.
And there was this one, I'm going to use the word tag, that was manually inputted by a human.
Mm-hmm.
And we ran it through the machine learning in conjunction with some control process data.
Yep.
And the machine learning said the biggest variation was the data that the human was entering. It was so funny, and everyone going, yeah, we expected that the human was not necessarily entering the truth. Okay, use the word. The humans interpret the situation and say, this is what's going on, and this is what I think's the capability of the plan.
Yeah.
But it was the one that was varying most.
Yes.
Rightly so. That's why we're human.
Yes, that's right. That's right. Mm-hmm. Awesome. Well, thank you, Seven. Thank you for your time. It's always a pleasure. And
likewise, mate. Likewise.
Those of you out there, thanks for following along. Leave comments. If you got any questions, hit us up. Subscribe, like, share. We try and just keep it real. And yeah, if you got anything you'd like us to talk about or would like to ask us, let us know. For now, thanks. See you later.